Hello, we're working with the Chapter 8, and Chapter 8 is a review of chapters 2, 3, and 4, and 9. So it's like a review of everything that you've covered thus far. And so, like I said before, the equations are not going to go away. So it's very important that you know how to solve your linear equations. Okay, so Chapter 8 is going to give you plenty of practice with solving linear equations. So looking at the homework, the first several problems are just about solving linear equations. All right, as you can see. All right, so basically, let's look at this one too. When you have a, let's do a similar, even ones with fractions. All right, so if you have one with a fraction, let's put this on the board. You have 3x over 4 plus 5x over 2 is equal to 13. And there are different ways of solving this linear equation. And basically, a lot of people like to get rid of the fraction. So we can do that also. And when you do that, you want to look for the least common multiple of your denominator. So we're looking at 4 and 2. And so what is your least common multiple? All right, so your least common multiple would be 4. So you're going to multiply all 3 terms by 4. Let's pick another color. So this one by 4, this one by 4, and also this one by 4. And note, because we're dealing with fractions over here, I can just put this over 1, so they're on level plane here. They're looking eye to eye, they're looking eye to eye. Now, you can multiply and then simplify, or simplify then, multiply. So let's just multiply. When you multiply the top, it's 12x. Multiply the bottom, that's 4. Top, so that's plus 20x. Bottom, that's 2. Here, just 13 times 4. Okay, so 52. And so now when you simplify these fractions, the fraction should disappear. So 12 over 4, you get 3x. See, it's gone. Plus 10x is equal to 52. Now, this is, a better equation for you to solve. We got rid of the fractions. All right, combine like terms. That's 13x equals 52. And so divide by 13, so x is equal to 4. There we go. Again, when you put it in your solution set, do not write x equals 4. So in your solution set, just put 4 inside the brackets. Okay, that's how you enter it. Okay, all right, so okay. All right, so when we get into the inequalities, just remember that when you are dealing with the inequalities, if you have less than or greater than, that's going to imply open brackets. So open, non-inclusive. If you have less than or equal to or greater than or equal to, then we use closed brackets. Close, meaning inclusive. Now, you just remember you cannot close negative infinity or positive infinity. All right, so keep that in mind. All right, so if we have this one, this is already solved for us. We have to choose the correct graph. So we have x is less than or equal to -7. Okay, so what does that mean? Okay, x is less than or equal to, all right? So if we look at a number line, we'll put 0 here, -7 to the left here, and we'll put +7 to the right. And so we notice that we have less than or equal to, so that means that's inclusive, okay? And then you say, what numbers are less than or equal to -7? So, but we know -7 is less than or equal to -7, okay? And then numbers go on to the left of -7. So So it would be a closed bracket, and I'll just write it above. Closed bracket on -7, and it's going to the left. All right, and so now, how do I write that in interval notation? So as an interval notation, really, if you have the graph, your interval notation is just pulled from the graph, okay? It's the least to the greatest, right? And so if we look at the least, that's going all the way to -infinity. So that's why it's -infinity, open, and that's going all the way to -7. That's the max, and that's close. So this is your interval notation right here. This is your graphical representation right there. So if we have to choose from the choices here, this would be E. Okay. And so you can click E and check. Good. All right, same thing with this one here, except we notice here that the it's x less than 5, so it will be open, okay? That will be open at 5 and going to the left. And so we can see this is the open bracket right here, okay, on E. So E, good. All right, and this one you saw. Let's see if we have another one that we can actually do. 10. All right, so that one same as an equation. All right, so we'll go back. We'll do this one. Go back to that. All right, solve the inequality, write the solution in interval notation, and graph it. So let's go. Now, just remember, I just want you to keep it in mind, it doesn't work here. However, if you do the rule here, rule when you're solving inequalities, is if you multiply or divide by a negative on both sides, reverse the inequality symbol. And so let me make that clear. So for example, you have -5x is less than 15. So to solve for this one, I would have to divide by -5. So I'm dividing by a negative on both sides. So I bring down my x, but my inequality reverses, okay? All right, so that's -3. So the x is greater than -3. And again, you would graph this, you can graph it and then write the interval notation. So we have -3 here and 0 here, 3 here. It's open bracket at -3, and that's x greater than, so I'm going to the right. Okay, and so again, you're pulling your interval notation off from your graph. So it's just like as it is, open at -3, going all the way to infinity. Okay, good. All right, so I just want to make sure that rule, just in case you run into it. All right, so now let's do this one. Solving this one. All right, so you have 5x plus 5 is less than 15. Solve this, -5 on both sides. 5x is less than 10. Divide by 2, so x is less than, divide by 5. That's what I need. I'm doing the answer. All right, so divide by 5. X is less than 2. Okay? All right, so now you're asked to, all right, so select the solution set, and so it says to type the answer in interval notation. So we have to type this in interval notation. So it might be better, I think it's better if you draw the graphical representation first. That way you can pull your interval from your graph. So x less than 2, what does that mean? That means open at 2 and then going to the left, pretty much. So open at 2, going to the left. So what is your interval notation for that? So the smallest would be -infinity and the largest is 2, and that's open. All right, so that's your solution in interval notation. Okay, -infinity, comma 2. Everything's open. All right, and so here we would pick A, and then we can use parentheses, negative infinity, comma, 2, close parentheses, and then check the answer for that. Good. And so now they're going to want the, let's see, do they want the graph? I'll continue. All right, so we've already graphed it, okay? So basically we had open at 2 going to the left. Good. All right, so now we get into the concepts of intersection and union, okay? And so note that intersection, the symbol is upside down U, okay? So the intersection, you think about when you have your sets, overlapping sets, okay? When they overlap, okay, that's your intersection. That's what they have in common. That's what they share, okay? And when you have a union, that's the U, okay? And then that's just everything, you know. What's in A, set A and B. All of it. When you say I do. All right, so if we look at this one, they want to find the intersection of this set that has the elements 2, 4, 5, 7, 9, and 10. And then this set, which only has the element 9. So what do they have in common? They have 9. That's it. So that would be your intersection. They do have an intersection. Okay. Now, if you wanted to write the union of that, and you don't repeat anything either. Okay. So it'll be 2, 4, 5, 7, 9. So I wouldn't write 9 twice. So, and 10. So it's everybody. That's the union. All right, good. Just want to make sure that's clear. And so here, this is dealing with the union. So the union of A and B. And so we have 7, 8, 9, 10, 11, 12 in this one, 7, 8, and 11 in this one. So the union is all of it because 7, 8, and 11 are in this one. So the union will be 7, 8, 9, 10, 11, 12. And so you just don't put parentheses around it. Just put 7, 8, 9, 10 with commas in between them. 7, 8, 9, 10, 11, and 12. So it'll just be set right here because this is already in this set. Okay, good. All right, so now you're looking at 2 graphs and to find their intersection. So intersection is what they have in common. So if I'm looking at these 2 graphs, I can see here, okay? So we can see what they have in common. Oops, let me pick another color. Okay. See what they have in common. See, they have 6, everything greater than or equal to 6. All right. So that would be your intersection, what they have in common. So this one right here. So B would be the intersection. Okay. And if you actually do the union, that would be here, all of it. Okay. It would be all of it. It would be A. That would be the union. Okay. You would include everybody. Okay. All right. So that's the intersection. And you only get one try. All right. So now we're getting into the absolute value. So let's go back and I'll give you some notes on that. So absolute value equations and inequalities. All right, so we got 3 cases that we're looking at. Okay, the first one is dealing with the equation. This is the only one that deals with the equation. So if the absolute value of x is equal to c, then you have 2 equations. So one equation is x is equal to c or x is equal to negative c. All right, and so basically an example, if I had the absolute value of x plus 3 is equal to, let's say it's equal to 9, okay? Now note that c has to be greater than or equal to 0. If c is negative, then it's no solution because the absolute value the absolute value of any number, okay, any positive or negative number is just positive, so it's not negative. So that's why you can't have an absolute value equal to a negative, because that's not true. It's not valid. So now you create from this absolute value equation, you create two equations. So this means that x plus 3 is equal to 9, or x plus 3 is equal to negative 9. Okay, so you drop the absolute value and it becomes two equations, and then you solve the equations. So again, the linear equations are not going away. All right, so here we have x is equal to 6, and we can see if we put 6 in here, then we have 6 plus 3, the absolute value of that. 6 plus 3 is 9. The absolute value of that is 9. And then here, you minus 3 on both sides, we get negative 12. Okay, so if you put negative 12 plus 3, that gives you negative 9, but the absolute value of negative 9 is 9. So that's an example of dealing with an absolute value equation. All right, so now these other two, dealing with the inequalities, if you have the absolute value is less than or equal to C, or less than C, okay, then this creates an and statement, actually, okay, intersection. So we can rewrite this as x is between negative C and positive C. So basically we have almost like the right hand side, and then we put like the negative C on the other side. All right, so that's case 2. Case 3 is when you have the absolute value is greater than C, greater than or equal to C. Then you have your, this is the union, so this is the or statement, okay? So x is greater than or equal to C, or x is less than or equal to a negative C. All right, so that would be your cases. So it's case 1, case 2, case 3. So let's look at the example here. So if we have the absolute value of x greater than 2, so that's dealing with case 3 on our notes, okay? So we have to solve. So knowing this is case 3, by case 3 then, that means x is greater than 12, or x is less than or equal to negative 12. So we don't really have anything to solve. I mean, to do, really, just to write the two. You know what that means. It says select the correct choice below, and if necessary, fill in the answer box to complete your choice. And so we have to write the solution set. So basically here, okay, if we look at the graph here, because we have to write it in interval notation, and this is an or statement. So if we look at this, this is 0, we'll say this is 12, and this is negative 12. All right, so let's look at this one. So x is greater than or equal to 12. That's including 12. Okay, and so we'll put, let's get another color. All right, so it'll be closed at 12, and then it's going to the right. Okay, but this one here, x is less than or equal to negative 12. And so less than negative 12, we're going to the left. So we close, going to the left. Now this is an or statement, so I'm including everybody. So let's write the interval notation for this one. All right, and so that's going to the left, that's going all the way to negative infinity. So that's negative infinity to negative 12, close. This one here is 12 is the smallest, and that goes all the way to infinity. Don't close it, and since I'm dealing with an or, that will be the union. So that's what you put in between, the union. So this is your solution. So that you would have negative infinity, comma, negative 12, okay, close at 12, union with 12, comma, infinity, okay? And so I might want to write that down. And we'll union with 12, infinity. All right, so this is a solution set. Oh, yeah, all right. And so we have negative infinity, comma, negative 12, close bracket, and then the union, and then close bracket, 12, comma, infinity. There we go. And then open bracket, because we're dealing with infinity. And so let's check it. Very good. Oh, we still got, okay. Well, we've already dealt with the, did the graph, because that makes it easier. So with the, yeah, but we need closed brackets at, all right, so here, this is the negative close here, close there. So let's see. Good. Good. So that really helps us out first by doing the, all right, so here we have a little bit more work. This is very similar to the last one, okay? Still the same case number 3. And that's dealing with the, oops. That's dealing with the, Okay, we got another problem. All right, so let's put this on the board. That's fine. So here, again, this is the case 3. So therefore, that would be 4 minus x greater than 10, or it's an or statement. 4 minus x is less than negative 10. And then you solve your inequalities, but just realize you're dealing with or statement. Or statement means includes, all of it, all together. And so here we have the minus 4. Oh, we have a negative x is greater than 6, right? Divide by negative 1. We divide by negative 1, what happens? We get x, reverse the inequality, negative 6. Or then you do the same thing, negative 4, bring down your negative x, less than negative 14. You have to divide by negative 1. So x is greater than 14. So now we have x is less than negative 6, or x is greater than 14. So let's look at that. All right, so we got 0 here, we got 14 here, and negative 6 here. So let me get another color. All right, so we have x is less than negative 6. So we know that's going to the left, open at 6, and then shade it to the left. X greater than 14, open at 14, going to the right. So it's very similar to what we did on the last one. So we can see that the interval notation for this one will be negative infinity to negative 6, but that's open, union with open at 14, and that goes all the way to infinity. Okay, so we did the graph and we did the interval notation. All right, again, you're dealing with the solving a system by graphing. This is from chapter 3. So let's look at this, okay? Because just to make sure you still remember how to graph. And there are different ways of graphing a linear equation, okay? And so the method that we've been applying is the XY intercept. All right, that's when you set one equal to 0 and solve for the other one. So if we look at the first one, okay, so we're looking at the x plus y is equal to 5. We can look, you can see, look at that, and you can do values of x, that correspond with y to give you 5, 3 and 2, or 2 and 3, or 1 and 4. So it goes on and on, okay? So it doesn't matter which way you do it. You can find 2 points easily. But we're going to use the x-y intercept, okay? So the x and y intercept. We'll put x and y intercept. So if we let x be 0, if x is 0, then we can see that 0 plus something equals 5. So we know that y has to be 5. And then if you put 0 for y, then x is 5. So we have 2 points already for that one. Now, with the second equation, we can still do the same thing. All right, and so put in, if you plug in 0 for x, so that will be 3 times 0 plus y is equal to negative 3. So that's pretty much gone. So we get y is negative 3. Now when y is 0, we have 3 negative 3x plus 0 is equal to negative 3. And so here we really have negative 3x is equal to negative 3. X is equal to 1. Okay, so we have 1. So we have 2 points. And so again, now you know how to graph it. All right, so let me write this down. We'll graph it. All right. So we got 0, 5, and 5, 0, and then 0, negative 3, and 1, 0. All right, so let me take this. All right, so we're going to graph, your graphing tool. All right, so 0, 5. Okay, I messed up. So let's clear that. Clear. All right, so let me use. Okay, 0, 5. And then 5, 0. Click. And then click the line tool again. And then 0, negative 3. You got to make sure that you are clicking the right point. And then 1, 0. Click. So we can see that we have intersecting lines, okay? And the solution is where they cross. So where they cross, it looks like it's at 2, 2, 3, okay? 2, 3 appears to be the solution. That's solving your system by graphing, okay? Good, so save it. All right, so that's solving by graphing. So we can check that. And we got the solution. We got, now you got to write it as a point, as an ordered pair. So we saw 2, 3. Let's see if we put that in right. Uh-oh. Let's click over a little bit more in the box. 3. Okay, 2, 3. All right, and so I just want to, we got 2, 3. I don't want it to go away. All right, so you already know how to solve it algebraically. Okay, and so looking at this algebraically, we already know the solution here graphically because we graphed it to get the solution at 2, 3. Let's look at it algebraically. So here, you can either use the substitution method or the elimination method. Those are the two methods that we use thus far. So if we wanted to use the elimination method, I mean, it doesn't matter which one you want to eliminate. Okay, both are good possibilities. Here, let's just get rid of the x. Okay, and so we can see this is a 1. This is a negative 3. So the least common multiple of 1 and 3 is just 3. So what happens, I need a 3 in one spot and a negative 3 in the other spot. We already have a negative 3 here. So I'm going to move this equation over. Negative 3x plus y equals negative 3. And we're going to multiply the first equation by 3. Everybody. Okay, on both sides. So that means we have 3x plus 3y is equal to 15. Okay, so now we can add. Okay, when you add, the x's should eliminate, and they do. So they do eliminate. They eliminate, and so you have what? 4y is equal to 12. Solve for y, you get y is equal to 3. Well, we can see we have 3 there. And so we have a y value. Once you get a value, right away you know you're dealing with intersecting lines. Okay? And so now we need to find the x value. So we can just use either equation, but I'd rather use the first one. X plus y equals 5. We know that y is 3, so that means that, okay, so if x plus y equals 5, and now we know that y is 3, so now we know that x is 2. So this is solving it algebraically. So we can see that we did get the right answer, even though we didn't check it yet. So we solved it by graphing, and then we solved it algebraically. Okay, so let's go ahead and check. Good. All right, good. So again, you're dealing with the elimination or substitution here. I would use the elimination when they say it. Say use the elimination method. really because the, and we're going to go ahead and solve this one. Okay. Let's go ahead and work this one also. All right. So here we can see, now, anytime that you can simplify, I would do so. Okay. You can see 21, 12, and 15 have something in common. But I'm not going to, let's just look, let's work it like it is. Okay. Let's work it like it is. All right. So which one do you want to eliminate? Decide that. So let's eliminate the X, and it doesn't matter. Okay. And so I'm looking at 7 and 21. The least common multiple of 7 and 21 is 21. Well, we already have a negative 21 in one position, so we need to get positive 21 in this position. So what do we need to multiply this equation by? 3. Good. So multiply by 3, everybody. So that will give you 21x plus 12y is equal to 15. Okay. And then we'll just copy the equation 2 as is. Negative 21x minus 12y is equal to negative 15. And so now we're ready to add. Guess what happens? So not only did we eliminate the x, we eliminate the y. So we get 0 on this side, equal sign, and then 15 minus 15 is 0. So what do you think? We have an identity here, okay? When that happens, 0 equals 0, all right, this really means that they're actually the same line, okay? So these are dependent. This is a dependent system here. They're the same line, actually. Okay, and so that means that there are infinitely many solutions and the equations are dependent. So the solution set is xy such that 7x plus 4x is equal to 5. I just wrote the first equation because they're the same. So it's B. This is your dependent. Now, if this whole side had canceled out, so if you had 0 and then this side and the other side gave you like 7, then this is not true. So that would mean that you have an inconsistent system. Okay. And that means that they're parallel lines. And that would mean the solution set is empty. Okay. Empty set, just so you know. All right. So that's that. Okay. Same thing here. Solving your systems. All right. So that's the chapter 8. Now you didn't have a whole lot on this one right here. All right. So the less than, but if you do have, I suppose we had the absolute value of x minus 3 less than 7. Okay. Then this is case 2. And so we would have negative 7 less than x minus 3 less than 7. So when you have a case like this, then the object is to get the x in the middle by itself. So it's like you're solving 2 inequalities at the same time. So we'd add 3, but in the middle, and I have to add 3 on the ends also. Okay, and so we get negative 4 less than x less than 10. So that's that. So when you graph this, it's just as it is. X is between negative 4 and 10. Okay, so we have open, open, and then shaded in between. Okay, shaded in between. There we go. And that's dealing with the case 2 when you have the absolute value less than C or less than or equal to. So you have, it's an and statement, but it's actually 2 inequalities solved simultaneously. But you want the variable in the middle. So, and even if you have to divide, okay, you would divide in the middle and on the sides. Okay, so I hope this has been helpful. If you have questions, Please let me know you're able to complete the homework.